Yep. Okay. So, who has seen absolute value before? Those two lines? Okay. Now, who for a starburst can tell me what do they know about absolute value? What does it mean? If you were to like just, somebody doesn't know, you're telling your little brother, trying to explain it. Okay?
Distance from zero.
Did you, by chance, look at the board for that?
No.
You knew that. Okay. Anyone else not looking at the board can see something else? What else is absolute value? Yeah, Vanessa? It's always positive because, perfect. And those are the two things I was hoping somebody would say. So you guys got it. It's a distance from zero. The reason why it's always positive is, how far is it to go from 0 to 4? 4. Like 4 steps, right? How far is it to go from 0 to -7? 7. 7. So absolute value is the distance from 0. It's always a positive number. The distance from 0 is the key thing to remember about that. Okay. So we had the distance from 0 as absolute value. We just want to review real quick our inequalities and how we're going to graph them because we'll have to do it on a number line. So this is a key. Less than, we know less than. Less than or greater than, less than or equal, greater than, and greater than. Now, some of these have open dots and closed dots. Who can remind me what a way to remember that? What's a way to remember that? Closed dot, open dot. I have a couple ways. Maybe you can add to them. Not really sure. Not sure. Okay. Does it take more ink from my pens that I replaced the ink for to make this symbol or to make that symbol? Which takes more ink? This one. Straightforward, right? So I know when it could be equal to, I put a closed dot there, and you could just remember it from the mnemonic device. Yeah, it takes more ink, so there's more ink, right? Or you could remember, it's possible for our variable to equal that value. Here, it could not equal that value. So if I have this number line right here, and I know it's x is greater than or equal to 3, here's 3. Open or closed dot? Closed, because it could be equal. The answer could be 3, right? This would mean the answer is 3, but now it's not equal to 3. It's greater than or equal to 3. So which numbers are greater than 3? Which one? Here's all the positives, right? Here's all the negatives. I mean, this is also towards, a billion. This is smaller numbers go this way. Okay, so I would then put the arrow going over. See? That's all we have to do for graph. We're going to have a few examples to work on with this, so don't worry if this doesn't click right away. Let's go ahead and see if we can graph this right here. So my steps that I do are throw a 0 in there, and then appropriately, put your other two values that are related to your variable like that. Okay. You don't have to make all the tick marks. You don't have to make everything perfect. You can just demonstrate abstractly what two values are in question. All right, go ahead and put the open or closed dot. Read it again and decide where the arrows go. And then show your neighbor. I'll give you guys maybe a minute and a half for this. Maybe a minute. A minute's good. All right, that's good. I see some people checking with their neighbor. Once you're done, check their neighbor real quick. All right. Who has a partner and yourself that are confident? Yes. All right. All the way through. Help me out.
So we did the circle with no ink.
Open dot?
Yeah, open dot.
For?
And we pointed it to the right.
For which number? Open dot?
For the 2.
Right. And then it's B is greater than, so where does it go? It goes this way. And then,
For
what's
5,
that?
there was a closed dot.
Good, good.
And for left.
Good. B is less than 5, less than or equal to 5. So here's 5. It has to be in the less area. So you see, sometimes we're going to end up with a line segment. Your answer is going to be between those 2 points. This is open dot because it's just B is greater than 2. It's greater than 2, so I know B has to be over here somewhere. B is over here. B is less than or equal to 5, so I know it could be 5, but it could also be values that are to the left. That's why we do those segments. You see, the answer could be 5. The answer could not be 2. It's like it could be 2.00001, but it can't be 2. See what I mean? Okay. Thumbs up, sideways, down for just being able to graph these guys. Good, 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 good. All right, perfect. So I'm going to give you a chance on your own. This is x is less than negative 2. X is greater than or equal to 5. So I would start like so. Here's 5. Here's negative 2. And then go to graph that for me. All right, then check with your neighbor. Check with your neighbor. Good, I see some checking. So then if you know you got it right, check for their sake. Like see if they got it right. Good. Yeah. Good, good, good. All right. Let's see. Grace, help me out with half the problem. Go ahead and do this side one over here. X is less than negative 2. So what am I going to do with that value?
First, find the number line, and then I'll put negative 2 on it, and then I did an open circle.
Open.
And then have the line underneath. And then put x is less than, so then I pointed it like to the left.
Perfect. Everyone agree? See some heads? Yep. None. Okay. How about x is greater than or equal to 5? Who can help me with that part? Yes.
So 5 is a closed dot,
Close.
and it's going towards the right.
Good. X is greater than or equal, so I know it's towards the greater numbers. All right. Thank you. Perfect. Thumbs up, sideways, down. Feeling even a little better. Okay. Thumbs. Good, good, good. All right. We are going to have to do a number line for these that we're going to have to solve. Now we want to approach this in the exact same way every time. It's called the positive negative switch. Okay. Now, here's the deal. If I have this answer right here, or sorry, this problem right here, what are my values for x that I can plug in there that will give me an answer of 6? Okay.
6.
Okay, we got 6. So I know x could be 6. I put 6 in there. It's equal to 6. What else could I put in there? Yes, Jude.
Negative 6.
Negative 6 also works. I can put negative 6 or 6 in there. You see how when there's absolute value, we have this positive option, we have this negative option. Okay. When we're dealing with inequalities, all these symbols, then we have to do not just a positive negative, but a switch. Okay? I'm going to show you what the switch is first before we go further. All right. Let's go ahead and look at this problem here, and let's branch it to the positive side and the negative switch. Okay, the positive and the negative switch. Now, the positive is nice because I just drop my absolute value symbols and rewrite the entire thing up. See, nothing really changes. It keeps it positive over here. Next, the negative switch. B minus 4, you know, those absolute values just drop. But watch. Switch, we switch, and we make the answer there negative. Okay. Solve these just like regular. We're going to solve them just like we had all last week. We were doing a lot of this. So I'm going to add 4. I'm going to add 4. B is greater than 10. Add 4, add 4. B is less than -2. Let's see. 0, -2, 10. They're both open dot. Here we have B is greater than 10. So I know it's going to be out there. B is greater than 10. Here we have B is less than -2. So we're going to go that way. All right. Okay. Now, just like we were solving equations, just like peeling an onion, you start on the outside, right? You start on the outside as far away from our variable as possible. Here's our variable. We see that we have variable -8, n -8 in the absolute value. All that's multiplied by 9. All of that is subtracted by 10. Now, if I am trying to get to the n, I want to think of, well, it's connected here by subtraction. It's connected here by multiplication. So I need to break my chains. I need to isolate my n value. So what I'll do is I'm going to start by actually adding 10. Adding 10. That's going to get rid of this chain. So then we have 9, n -8, and less than 36. All right. What's next following that same kind of process? Leah.
It's 26. Oh, never mind.
Got it?
Never mind.
Always double check me.
I got it.
All right, that's fine. Okay.
Divide by 9.
Divide by 9. Perfect. We're trying to get into the n. It's absolute value, so these are kind of like different functions. I'm not going to distribute that. I'm not going to distribute that. The absolute value changes that rule a little bit, so that's gone. n -8 is less than 4, and now I want you just to do the positive, negative switch. And graph it. I'll let you work all that out. Probably like 2 minutes here. I see a lot of people finish up the graph, so double check over with your neighbor. Double check with them. Okay, let's see. Oh, yeah. Okay. Solomon, what do you think? Can you give me my first step? What is my first step going to be with this? Yeah. What do you think with this one right here? You want to ask someone else in your group real quick? There it is. You do it. Divide by 3. I'm trying to isolate x. Divide by 3 allows me to cancel those 3's out. Absolute value of x plus 6. is greater than 2. What's next? Now it's time to what?
Subtract.
Switch.
Do the positive negative switch. So we wouldn't be able to subtract it because we have absolute values still. We need to split them to the positive negative switch. X plus 6 is greater than 2. X plus 6 is what? What goes over there? Less than
-2.
2. Okay, solve them out, graph them. I know that's going to be 2. Well, I don't know yet. You don't know. Okay, subtract 6, subtract 6. X is greater than -4. Greater than. Again, X is less than -8. Okay, let's put them in there. So, you can throw a 0 there for reference. -4, -8. Are these going to be open or closed dots?
Open.
Open. Are the arrows going to go out, in, both to the left, both to the right? Out. Good. X is greater than -4. Whoops, that's the wrong place for that. Greater. X is greater than -4. X is less than -8. All right, so far so good. Okay. Good. Thumbs up, sideways down for doing this. It's a couple steps, right? Negative switch. Okay. 2 more examples. This is an awesome example. Awesome. There's one thing that we cannot have. Is there a way that I can have something absolute valued and then that equals a -2? Can you ever take the absolute value? Essentially what's asking is it possible to have a distance from 0 that's a -2? No. Absolute value makes everything positive. So anytime you have that negative part of the inequality out here, because this is negative, we have no real solution. Okay. We have no real solution. That means that there isn't a way to get a proper answer with this, with the math we know right now. So anytime it is equivalent or inequality compared to has a negative on this side, you cannot solve it. So we just can go right to no real solutions. We started with a negative. Okay. That's going to be key. There's one problem on your worksheet that has that, I think. And this is, we've already done this example. We've done a few examples. Okay. Did a weird order. All right, thumbs up, sideways down. If I see sideways, I'll do one more example. So just kind of give me some feedback with it. Yeah, yeah, okay. One more example. Okay, how about this? X minus 1 plus 5 is greater than 6.
For the right side? No, back on the reading. The -73. The no real solution?
Oh, okay, yes.
Yeah, does that go, does that rule still go if it's on the left side?
No, it's going to be, if this entire expression was reversed, like this was over here and that was over there, then it would still apply. So it's just when the equation or inequality has the variable side relating to some constant over here that's negative. Yeah. It's kind of like a minor point. It's a minor point that we got to add. Okay, so we know we're going to subtract 5. So we get x minus 1 and the absolute value is greater than 1. Let's do the switch. X minus 1 is greater than 1. X minus 1 is less than negative 1. You add this, you get x is greater than 2. You add it here, we get x is less than 0. Okay. So if I had to put this on a number line, 0, well, that's not the place for it. 2, 0. X is less than 0. X is greater than 2. That's it. Can we do this? I think we can do this now. All right. Let's see. Let me see what subscription tally I have. Let's see. What do you think? 216. And I know that means a lot of you still haven't added. So, you know, you could get the prize of King Size Kit Kat. 250th person to subscribe. A lot of you haven't even subscribed. Are you guys waiting until it's like 242? 248? Oh, man, don't do that. Don't do that. Okay, so let's see. We can get a Kit Kat if we subscribe and we're 250th. So let's just do subscribe on 3. That work? You gotta be loud. I want Mr. Laird to hear this. Okay? All right, subscribe on 3. 1, 2, 3. Subscribe! Think you heard it? I need someone to go check if you heard it. All right, we're good. Subscribe, please.